Friends, welcome back to our channel Taxmaster. In this video I will discuss about what is coil. So here some websites are open. So what is coil? So we going this is a YouTube, so we'll back this, and we learn from third website, which is a detailed article, and this is a very good article written. So we back, and we are going to what is coil in electronics. So we going to second website, and here some detail about coil. The article This article focuses on the coil as an electrical component with an inductance. Its application and actuator is lifting, magnetic and similar devices covered under. So in electrical engineering, a coil, this is the diagram of coil. You see on your screen. I zoom it. So this is the different types of coils. In electrical engineering, coils are one of the hand winding and good that are suitable for generating or detecting a magnetic field. They are electrical components or are part of a device such as transformer, relay, electric motor, or loudspeaker. On the other hand, separate coils are inductive passive component. Those essential property, it is defined inductance. They are mainly used in the field of signal processing for frequency determining circuit, resonant circuits, low pass filter, high pass filter, band pass filter, signal phase characteristics correcting for interference suppression to the current flow, smoothing, or as energy stored in switching power supplies, and many other electrical and electronic equipment use. The frequency of use of coil, however, much lower than that the resistors and capacitor, since these are often cheaper and easier to manufacture and can also be integrated more cheaply in electronic semiconductor circuit. In electronic circuit design, the use of coil is avoided if at all possible. If they can be simulated with capacitor, resistor, and active component transistor. For example, by means of a gyrator circuits, most coil consist of at least one winding of current conductor made of wire, enameled copper wire, silver plated copper wire, or high frequency stranded wire, which is usually wound on a bobbin and is predominantly provided with a soft magnetic core. The winding arrangement and shape, the wire diameter, the winding and the core material determine the value of inductance and other quality properties of the coil. In addition, spiral-shaped conductor tracks on printing circuit boards, which are optionally surrounded by surrounding ferrite cores, are coil in the sense of an inductive passive component. The turns of a coil must always be insulated from one another and form the coil core, which is often electrically conductive in order to prevent a winding short, which would significantly impair the function of the coil. In the case of coil and winding made of enameled copper wire, the individual layer of winding additionally isolated against voltage breakdown of lacquer paper. So printed circuit, diagram of printed circuit. This is the circuit symbol of a coil. Coil is a wound wire with the turns isolated from one another. One turn is one revolution, including the supply lines. There are only integer number of turns. A winding body coil does not necessarily have to be present if the winding body is missing or if it is made of non-magnetic material. One speaks of air core coil in the mechanical or electrical sense. The coil body must only serves to mechanically stabilize the wire and unlike the coil core has no magnetic influence. Coils are also available in a flat spiral shape and with a rectangular or any other shaped coil cross section. You can also be implemented as a spiral conductor track directly on a circuit board. Coils have a certain inductance. This inductance can be their actual purpose, choke coil, filter coil, or only a secondary property, a transformable magnetic relay coil. In electric motor, the coil are used as a winding and set. In propane coil refer to a coil line. In addition to the wound wire and the bobbin, the coil often just a coil core inside the increase the inductance. The word coil indicates the type of construction. The inductance of a coil is measured in unit Henry. The main property of coil is their inductance. The inductance results from the number of turns of coil, the material enclosed by the coil, and the dimensions. Due to magnetic linkage of individual winding with one another due to close proximity of the individual winding, the inductivity of wound coil theoretically increase as the square of the number of winding, a double of the number of turns with the same geometric dimension, thus result in coupling of the inductance. If an electrical voltage is applied to the terminal of coil, the current which flows through the voltage source in experiment does not change suddenly. With an ideal core with the inductance of 1 Henry and a voltage of 1 volt, the current had increased to the 1 ampere also after 1 second. A voltage can be also rise at the ohmic resistance, and the other name of ohmic resistance is internal resistance of a non-ideal coil itself. Coil is basically used to reduce the fluctuation of a circuit or at a resistor inserted in the circuit of coil. The change in the current due to applied voltage or the voltage drop only comes to a standstill when the current at the internal voltage resistance create a corresponding counter voltage. A short circuit ideal coil compares superconductor theoretically never discharge simultaneously with the current through the coil wire. A magnetic field is created in the coil. A changing magnetic flux of an externally applied magnetic field generates an induction current on a short circuit conductor loop and a corresponding self-induction voltage at the end of the open electrical conductor. This voltage is directed in such a way that its counteract it cause the current. An increase in the rate of change of magnetic flux lead to an increase in the voltage that opposes the current. The proportionally factor between the current that change over time through the conductor and the result self-induction voltage is called inductance. In addition to the actual desired inductance, real coil also have other generally desirable electrical properties such as electrical resistance, parasitic capacitance, and thus at least one electrical resonance point. Resonance parallel resonance circuit, or in the case of coil cord that increase the inductivity, distributive resonance, and eddy current losses. All these parameters are temperature and working frequency dependent. It's therefore only sensible to use them up to a component typical maximum cutoff frequency where there is still sufficient inductive reactance or phase angle is corresponding insert circuit. So this is the one part of a coil. In other video we will discuss the other part of coil, which is always leads to increase in voltage that oppose the current. So in other video we will discuss the coil, the inductive reactance or phase angle in the corresponding insert circuit. So if one on the other hand a high quality resistor consisting of a long wound resistance wire has a particularly low inductance, the mechanical resistance wire carrier a porcelain tube with contact clips floor wound with a wire running in the opposite direction. The opposing magnetic fluxes almost cancel each other out. This method is used, for example, a wound load resistor for high magnetic field resistor, high low frequency range, and other kilohertz.